Last time we talked about the copper plating process. We give the PCB a basic conductive copper layer. Next, the board will enter the key pattern plating process.
The outer circuit of the PCB board has been completed, and the copper surface of the circuit part has been exposed. This is the core part that the customer needs. The areas that do not require electroplating are tightly protected by dry film. Entering the electroplating copper stage, when the current passes through the electroplating solution, the metallic copper at the anode undergoes an oxidation reaction and dissolves into the solution in the form of copper ions. As for the PCB board serving as the cathode, its circuits and vias carry negative charges, which will attract copper ions from the solution. Copper ions gain electrons at the cathode, undergo reduction reactions, and deposit on the circuit and via surfaces of the PCB board, continuously thickening the copper layer until the thickness standard specified by the customer is reached. This process effectively increases the copper layer thickness of the circuits and vias, enhancing the overall conductivity and electrical reliability of the PCB board. After copper plating is completed, the next step is tin plating.
A thin layer is evenly placed on the copper plate area. This thin layer will serve as an anti-corrosion protective layer. In the subsequent alkalization process, it can effectively resist the corrosion of the copper layer by etching solution, ensuring the integrity and the accuracy of the circuit pattern.
At this point, the copper and tin electroplating steps of the graphic electroplating process have all been completed, and the circuit performance of the PCB board has been significantly improved, laying a solid foundation for subsequent processing.
Today's pattern plating process ends here. Thank you for watching. Please follow us and see you next time.